Hello everybody, welcome into another lesson. So today we are going to talk about how to evaluate trigonometric functions of any angle. And in this lesson you're not going to know what the angle is, but it really doesn't matter. Now in the previous lesson we did everything based off a default radius of 1, which is what those values of the trig functions that we did in the last lesson have, is a default radius of 1. But let's say you have an angle and the terminal side has a given xy coordinate. Well, that terminal side is your radius. Well, you need to find the length of that radius to be able to evaluate your trigonometric functions properly. So how are we going to do that? Well, keep in mind your x units are how many ever, of course, it goes over left or right, correct? So what you want to do is set yourself up a right triangle. Set yourself up a right triangle, make your life a lot easier. So that's your x value, of course, right? It goes over x units and then up y. So you have x and y. And then by taking Pythagorean Theorem, we can solve for r. This would simply be x squared plus y squared equals r squared, which would then give you that r equals the square root of x squared plus y squared. And of course, we're only considering the positive square root because the length can only be positive. Now, you're also then going to be asked to evaluate the 6 trig functions for each angle. So, of course, if we want to find the cosine of theta, in this case, it's the adjacent over the hypotenuse, right? So it's going to be your x-coordinate over r. And when your default radius is 1, it's just your x-coordinate. So that's where the whole thing came from in the last lesson, with a default radius of 1. Your sine of theta is going to end up, of course, being the opposite over hypotenuse, so it would be y over r. And then your secant of theta, that's the reciprocal of sine. Reciprocal of x over r would be r over x. And then your cosecant of theta would end up, of course, being the reciprocal of sine. Reciprocal of y over r is, well, that's r over y. And then you have a tangent of theta, which that's opposite over adjacent. That'd be y over x. And then your cotangent of theta is your adjacent over opposite, so that would be x over y. So those are how we're going to evaluate these trig functions today in this lesson. So let's go ahead and get into some examples here. All right, so we have our first one here. So we have the coordinate here, negative 12, 5. So we have a coordinate here on the terminal side of the angle 12, 5. So here is our angle, here's theta. On the terminal side is the coordinate 12, 5. We need to find the radius. Well, let's go ahead and set ourselves up a right triangle. That's going to make our lives a lot easier. So the x is over negative 12, and then the height is 5, so it's up 5 units, so we're definitely in the second quadrant. Well, let's go ahead and find the radius. So the radius squared equals what? That's going to equal that negative 12 raised to the second power plus our 5 raised to the second power. So that would equal 144 plus 25, which means r squared equals 169, which means our radius r is 13. So we now found the radius to be 13. Let's go ahead and find the values of the 6 trig functions. So the cosine of theta is going to equal your adjacent, of course, over your hypotenuse. So negative 12/13 is what you would get for your cosine. And that makes sense since we're in the second quadrant. You'll get a negative cosine. Now what about your sine? Your sine, of course, is going to be your opposite over hypotenuse. So that would be 5/13. Now we can take the secant of theta, which is 1 over the cosine. So 1 divided by negative 12/13, that would give you negative 13/12. Then we can find the cosecant of theta. So that's going to be 1 over your sine. 1 over 5/13 would be 13/5. And then we can find the tangent of theta, which is going to be opposite over adjacent, so that'd be negative 5/12. And then your cotangent of theta, that's 1 over your tangent, so 1 divided by negative 5/12 would be negative 12/5. So that is how you would find the given trig functions for any angle. And really, and truly, we're actually doing it for this angle here, which is our reference angle, which we call theta prime. That is the reference angle. But it's based off of this. It's just the reference angle. So we're doing the same thing here, just for the reference angle. So that's what we're really referring to here. And I got more. Try not to completely destroy this. That's okay, I can redraw it if I have to a little bit. Alright, what's the next one here? So we have a big angle here, so we have the coordinate -6, -8. So we got the coordinate -6, -8. So we're going to find the trig values for this angle. But again, go ahead, set yourself up a right triangle, which really we're going to find it for the reference angle. So this is over -6, so this is going to have a length of -6, and you're down 8, so this leg here will have a length of -8. Here's your radius. Here's your theta prime, which we're really finding for the reference angle. So here, this is a right triangle, of course. I should specify that. Okay. So let's go ahead and find our radius. So the r squared equals that -6 squared plus that -8 squared. We're definitely in the third quadrant, you can see. So that's going to equal 36 plus 64, which means r squared equals 100. So r, which is your radius, equals 10. So the radius has a length of 10. Now, at this point, we can proceed to finding the 6 trig functions. So let's find the cosine of theta, which would really be cosine of theta prime, because we're doing it for the reference angle. But the cosine That's your adjacent over hypotenuse, negative 6 over 10, which would be negative 3/5. So the cosine would be negative 3/5. Now let's find the sine. Well, that would be opposite over hypotenuse. That'd be negative 8/10, which would be negative 4/5. Now let's find the secant of theta. That's 1 over cosine, so 1 divided by negative 3/5, that's negative 5/3. Now what about the cosecant of theta? That's 1 divided by sine, so 1 over negative 4/5, that'd be negative 5/4. And then we can find the tangent of theta. So that's opposite over adjacent. Negative 8 over negative 6 would actually give you positive 4/3. And then your cotangent of theta, that's 1 divided by your tangent. 1 over positive 4/3 would be positive 3/4. So you see, just like the last lesson, everything's holding true for your cosine and sine and tangent and cotangent and secant and cosecant values as far as being positive and negative, because we're in the third quadrant here. And I got plenty more. All right. Reconstruct that little piece here. All right, what do we got next? Back in the second quadrant here, we have the coordinates negative 9, 14. So we have an x-coordinate of negative 9, a y-coordinate of 14. Well, here's the angle we're actually going to be evaluating here. There's theta. But we need to set ourselves up a right triangle. And really we need to find theta prime, which would be right there. Well, we know in the x we're over 9, so that'd be negative 9 for the x part. The sine is 14, it's up 14, so we need to find our radius. So radius squared would equal that negative 9 squared plus 14 squared. So that's going to equal 81 plus 196. Which means my radius squared should be 277. But let's see if that breaks down any further. Let's see if we can break down 277 any further, because that's probably not going to be very pretty. I don't think it's going to. Nope, we're literally stuck with the radius equals the square root of 277. So you get a radius of the square root of 277. That's not a pretty one, but that's exactly what it is. But we can go ahead and find the value of the 6 trig functions. So the cosine of theta, well, that's going to equal your adjacent over your hypotenuse. So that would be negative 9 over the square root of 277. And let's go ahead and rationalize the denominator. because that's how the only way you get an acceptable answer. So that means your cosine of theta would equal -9 times the square root of 277 all over 277. Not a pretty answer. Now, what about the sine of theta? Well, that's going to equal the opposite over your hypotenuse, so that would be 14 all over the square root of 277. So then rationalize your denominator. Which then means that your sine of theta is 14 times the square root of 277 all over 277. Alright, now let's go ahead and find the secant of theta, which we know is hypotenuse over adjacent, so that would be negative of the square root of 277 over 9. Let's find the cosecant of theta, which we know is hypotenuse over opposite, so that'd be the square root of 277 all over 14. Then we can find the tangent of theta, which is the opposite over adjacent, so that'd be -14/9. And then the cotangent of theta, that's the reciprocal of the tangent, so you would get -9/14. That would be your cotangent. So sometimes you're going to have rather hideous answers, unfortunately. Alright, let's just do that number there, because this is just really awful. Alright, what's next? Back down the third quadrant, we have the coordinates -12, -15. So we're at -12, -15. So here is the theta which we're evaluating for that angle, but set yourself up a right triangle here, so let's do that. Now that -12 tells you the length of your x, that -15 tells you the length of your y, so we can use these to find the radius, which really we're going to find the angle, we're going to solve for theta prime, which is the reference angle between theta and 180. So we're going to take x squared, which in this case is, we'll have r squared equals that -12 squared plus that -15 squared, which means it'll be 144 plus 225, which means your radius squared should be 369. Let's see if that 369 could break down any. I really hope it does, because that's probably going to be another awful one. It does a little bit. It breaks down into the square root of 9 times 41, so that means your radius will be equal to 3 times the square root of 41. So that's your radius is 3 times the square root of 41. Now we can go ahead and find the 6 trig functions. So cosine of theta, well, that equals your adjacent of -12. That'd be -12 all over 3 times the square root of 41. which could simplify into negative 4 over the square root of 41, but we need to rationalize the denominator. So multiply both numerator and denominator by that square root of 41, and you get your cosine is equal to negative 4 times the square root of 41 all over 41. Now how about the sine of theta? So that's opposite over hypotenuse, so that would be negative 15 all over 3 times the square root of 41, which would simply end up being negative 5 all over the square root of 41. But let's rationalize both numerator and denominator. So this should end up turning into negative 5 times the square root of 41 all over 41. Alright, now let's find the secant of theta. That's your hypotenuse over adjacent, so that would be 3 times the square root of 41 over negative 12, which would just end up giving you negative of the square root of 41 over 4. Let's find the cosecant of theta. That would end up being your hypotenuse over opposite, so that'd be 3 times the square root of 41 over negative 15, which would end up giving you negative of the square root of 41 over 5. And then we can easily find tangent and cotangent. Tangent is opposite over adjacent. Negative 15 divided by negative 12 will turn it positive. That become positive 5/4. So the tangent isn't so bad. And the cotangent's just the reciprocal of the tangent, which would just make this 4/5. So we had a lot of fun with that one, that's for sure. I got more. All right, let's see here. This one shouldn't be so bad. I'm probably way overdrawing this, but we have a coordinate of negative 1, 1. So this time on the radius, on the terminal side of the angle, we have a coordinate of negative 1, 1 for our theta. Well, let's go ahead and set up a right triangle. So that coordinate tells us our x is negative 1, our y is positive 1. So we can find our radius, and we're actually going to solve for theta prime. So radius squared would equal that negative 1 squared plus the 1 squared. So that would equal 1 plus 1. So the radius squared equals 2, meaning the radius just equals the square root of 2. So the radius equals the square root of 2, so now we can go ahead and find the value of the 6 trig functions. So the cosine of theta, that equals your adjacent over your hypotenuse, negative 1 over the square root of 2, that would be negative of the square root of 2 over 2. Now let's find the sine of theta. That'd be opposite over hypotenuse, so 1 over the square root of 2 is the same as positive square root of 2 over 2. Alright, now the secant of theta, that's going to equal then, of course, the hypotenuse over your adjacent, so that'd be negative of the square root of 2. Cosecant of theta equals hypotenuse over opposite, so that'd be positive square root of 2. Then the tangent of theta, well, that's just simply opposite over adjacent, that'd be negative 1. And then cotangent of theta would also be negative 1. And I'm sure some of you are realizing we solved for a 45-degree reference angle. In fact, this was 3 pi over 4, which was 135 degrees. So it actually worked out. We had a special angle this time. But it doesn't work out that way every time. And in the next lesson, we're going to get into inverse trig functions, where we could actually find out what these angles are, too. There's ways to find out what these angles are. But that involves inverse trig functions, which that's the topic of the next lesson. Those are interesting in and of themselves. Alright, what's next? We're down in the fourth quadrant. So let's see. We have the coordinate 15, negative 8. So we're actually in the fourth quadrant this time. Well, same process here. Of course, we're going to solve for theta. We're going to find the 6 trig functions for theta. But we're going to draw ourselves a right triangle here to help. So here's our right triangle. Our x has a length of 15. Our y has a length of negative 8. We need to solve for the radius. So really we're going to be figuring out theta prime, which would be the reference angle. Okay, so let's find r squared. That's going to equal our x squared, which would be 15 squared plus that negative 8 squared. So that's going to equal 225 plus 64, which means r squared equals 289, and it turns out the square root of 289 is exactly 17. So that radius has a length of 17. Now we can find the value of the 6 trig functions. So let's see, the cosine of theta, that's going to then be adjacent over hypotenuse, so that would be 15 over 17. The sine of theta equals the opposite over hypotenuse, so that would be negative 8 over 17. Now let's find the secant of theta. That's just 1 over your cosine, so that would be 17/15. And then the cosecant of theta, that's just 1 over your sine, so that would be negative 17/8. And then let's find the tangent of theta. Well, that's opposite over adjacent. You would get negative 8/15. And then your cotangent of theta, well, that's just 1 over tangent. You would get negative 15/8. So that one also wasn't too terrible. At least we didn't have any radical radius this time. It was all whole numbers, which was really nice. Okay, got a few more here, about 5 more. All right. What's the next one? Another fourth quadrant one. This time we're located at the point 6, -9. Here in the fourth quadrant, 6, -9. So let's go ahead and find this theta, which really we'll be solving for theta prime, but which would be the reference angle. But let's draw ourselves a right triangle here to aid us. Okay, so our x is 6, our y is -9, so now we need to find the radius. So the radius squared is going to then end up equaling 6 squared plus that -9 squared, which would equal 36 plus 81, which means the radius squared would equal 117. Well, let's see if that radius breaks down at all. The radius squared. It breaks down into the square root of 9 times the square root of 13, which means the radius would equal 3 times the square root of 13. Alright, so here's our radius of 3 times the square root of 13. A little bit of a radical, but not the worst thing I've ever seen. Okay, so now we can find the value of the 6 trig functions. So cosine of theta, which would really here be theta prime, that's adjacent over hypotenuse, so that'd be 6 all over 3 times the square root of 3, which is going to equal 2 all over the square root of 3 times the square root of 3 all over square root of 3, which would mean your cosine is 2 times the square root of 3 over 3. So there's your cosine. Now let's find the sine. Sine of theta is opposite over hypotenuse. You know what? This should be 13, excuse me. Well, the square root of 13, I don't know where I got that 3 from, but it's still the same idea. 2 times the square root of 13 over 13. So, pardon me. So, opposite over hypotenuse for my sine, that'd be -9 over 3 times the square root of 13, which would turn this into -3 all over the square root of 13 times the square root of 13 over the square root of 13, which means my sine is -3 times the square root of 13 all over 13. Alright, now finding the rest shouldn't be so bad. To find the secant of theta, that's just your hypotenuse over adjacent. So 3 times the square root of 13 over 6, this would turn into just the square root of 13 all over 2. Now let's find the cosecant of theta. That's my hypotenuse over opposite. So 3 times the square root of 13 over -9. That'd be negative of the square root of 13 all over 3. Now let's find the tangent. Tangent equals opposite over adjacent. So -9 over 6, that'd be -3/2. And then my cotangent's the reciprocal of tangent, so that would end up being -2/3. I have about 4 more. I got 4 more this time. Alright. What have we here? We're in the first quadrant this time. So we have the coordinate 7, 10. So we have the coordinate 7, 10, so that means we're in the first quadrant, but let's draw ourselves a right triangle here to aid us, and we'll actually just be finding theta this time since it's in the first quadrant. So x is 7, so we're over 7, we're up 10 for the y, so let's find the radius. So r squared would then equal that 7 squared plus that 10 squared, which would give us 49 plus 100, which then means that r squared equals 149. Let's see if 149 breaks down at all. I don't get very good feelings about it, but let's see. It doesn't. So the radius is going to be the square root of 149. So unfortunately, we're stuck with a hideous expression. So let's go ahead, start working on the cosine of theta. Cosine of theta, well, that's the adjacent over hypotenuse, so that'd be 7 over the square root of 149. But let's rationalize the denominator. So that means your cosine is going to equal 7 times the square root of 149 all over 149. So there's your cosine. Now let's find your sine. So the sine, well, that's your opposite over hypotenuse, so that'd be 10 over the square root of 149. But let's rationalize the denominator here. So that's going to then equal 10 times the square root of 149 all over 149. So there's your sine. Now let's go ahead and find your secant. Secant, of course, is hypotenuse over adjacent, so that would just give you the square root of 149 over 7. Now let's find your cosecant. That's going to equal the hypotenuse over opposite, so you would get the square root of 149 over 10. Now let's find the tangent of theta. That would give you opposite over adjacent, so that would give you 10/7. And then your cotangent's just the reciprocal of tangent, so the reciprocal of 10/7 would give you 7/10. So there's your cotangent, it would be 7/10. Alright, got 3 more. What do we got here? We're actually going into the fourth quadrant again. We are at the coordinate 1, negative square root of 3. So we're in the fourth quadrant at 1, negative square root of 3, which means, of course, we're going for this angle here. We're going to go for theta, but we want to find the radius to be able to solve for the 6 trig functions. So let's set ourselves up a right triangle, which really means we'll be going for theta prime, the reference angle. So in x units we're over 1, and y units we're down negative square root of 3, so we need to find the radius. So the radius squared would equal that 1 squared plus that negative square root of 3 squared, which would give you 1 plus 3, which means your radius squared equals 4. which simply means your radius equals 2. So now we know the radius to be 2, we can proceed to find the 6 trig functions. So let's find the cosine of theta. That's adjacent over hypotenuse, so that would just be 1/2. So the cosine's 1/2. Now how about the sine? Sine of theta is opposite over hypotenuse, so that'd be negative of the square root of 3 over 2. Alright, let's find the secant. Secant is just reciprocal of cosine, so the reciprocal of 1/2 is 2. Let's find the cosecant of theta. Well, that's going to be hypotenuse over opposite, so that would be negative 2 over the square root of 3 times the square root of 3 over 3, which means your cosecant is negative 2 times the square root of 3 all over 3. Now all we have left are the tangent and cotangent. So the tangent is opposite over adjacent, so that would just be the negative of the square root of 3. The cotangent is the reciprocal of tangent, so you would just end up getting negative of the square root of 3 over 3. Alright, I got 2 more. See where we'll end up next. Alright, 2 more. Down to the third quadrant again. We have the coordinates negative 3, negative 4. So we're going to find for theta. But first let's set ourselves up a right triangle. So let's go ahead and do that to make our lives easier. And we'll be dealing with the reference angle theta prime. Alright? Well, in x we're over negative 3, and sine we're down negative 4, so let's find the radius. So radius squared is going to equal that negative 3 squared plus that negative 4 squared, which would give you 9 plus 16, which means your radius squared equals 25, or just simply giving you a radius of 5. So your radius would be 5, so that's going to make life a lot easier since we don't have any radicals. So let's find the cosine. The cosine, that equals the adjacent over hypotenuse, so that would be negative 3/5. Let's find the sine of theta. That's opposite over hypotenuse, so that'd be negative 4/5. Let's find the secant of theta. That's just the reciprocal of the cosine, so that would be negative 5/3. Now let's find the cosecant of theta. That's the reciprocal of sine, so that'd be negative 5/4. Then we can deal with tangent and cotangent. So the tangent of theta, that equals the opposite over adjacent, so negative 4 over negative 3, that'd be positive 4 over 3. And then the cotangent of theta, that's the reciprocal of tangent, so you would get 3/4. So there's your 6 trig functions for that angle. We got 1 more, and then we're done with the lesson. Alright, what do we got? Looks like we're in the second quadrant. So we got the coordinates negative 15 and positive 5 times the square root of 7. So that's going to be a bit of a doozy. So, of course, we're going to find for theta. But first, set yourself up a right triangle to make your life a little bit easier. So, which means we'll be really finding for theta prime, the reference angle. Okay, so we're to the left 15 units, so we'll have negative 15 for the x, up 5 times the square root of 7 for y. So now we need to find our radius. So the radius squared equals that negative 15 to the second power plus that 5 times the square root of 7 raised to the second power. Well, negative 15 to the second power, that's positive 225 plus, okay, so what is 5 to the second power? That's 25 times 7, that's 175. Which means my radius squared actually equals 400, which means my radius is a perfect 20. So I end up getting 20 for my radius. Alright. Now we can go through and find the value of the 6 trig functions. So let's find the cosine of theta. So that's going to be adjacent over hypotenuse. Negative 15 over 20 is negative 3/4. So there's my cosine of negative 3/4. So then the sine of theta, that equals opposite over hypotenuse. So 5 times the square root of 7 over 20, that would just be the square root of 7 over 4 for the sine. Now let's go ahead and do the secant of theta. That's just the reciprocal of the cosine, so you would get negative 4/3. Now here's where it gets fun. Let's do the cosecant of theta. That's the reciprocal of sine, so that'd be 4 over the square root of 7, but we need to rationalize the denominator. So that means your cosecant is actually going to be 4 times the square root of 7 all over 7. Alright, now we need to find tangent. The tangent of theta is equal to your opposite over adjacent. So that'd be 5 times the square root of 7 over negative 15. That would give you negative square root of 7 all over 3 for your tangent. And then your cotangent is simply the reciprocal of tangent. So that would equal negative 3 all over the square root of 7. But let's rationalize that denominator. So that means your cotangent is going to be equal to negative 3 times the square root of 7 all over 7. So that is how you deal with trig functions in general for any angle. If you have a radius with a x and y coordinate, you would just use Pythagorean Theorem to solve for your radius, and then you can set up your trig functions and find out what they are. Now in the next lesson, we're going to switch to inverse trig functions, which will be where we'll solve for the angle. So I hope everyone has a great day. Take care.